And again, we're starting our factoring, okay? You guys, I'm sure, did a lot of factoring in Algebra 2. We're going to do a lot of factoring in this class. There's a lot of, this is math for college algebra, so it's a lot of algebra, and most of algebra has some sort of factoring involved somewhere. So we're going to talk about the different ways that we factor, different times that we factor, different ways, that sort of a thing. But the first thing you should always look for is a GCF. So this first page, all we're doing is working on pulling out a common factor, meaning both not only a number, but also your GCF can be a letter or a combination of the two. We're also going to factor today where the A term is not equal to 1, and I'll talk to you about that in a second. But if we look at these, and we're going to do all these together. I know it seems like, oh my gosh, it's so much. It's okay. We're going to do them all together. This is really good practice. So when we look at number 1, all right, it says factor out the common factor in each expression. Like I just said, your common factor can be a letter, or it can be a number, or you can have both situations. When we get into more complicated expressions, you might have a GCF and then factor a trinomial, a special product. You might have a bunch of things all in one problem. So we're going to focus on one thing at a time right now. So if I look at number 1, this is how I want you guys to do this, to really get in the habit. Some of you, I know this is probably elementary to you, and you're like, oh, I know how to do this. That's fine. Just follow along with me to make sure, God bless you, that we have everything under control. What do you notice? What can you take out of both 8 and 6x to the 4th? 2. You can take out a 2. You can divide out a 2. Guys, that 2 is not going anywhere. You're just moving it from one place in the expression to another. So I'm going to rewrite that 2 out in front. And then I'm going to do the division. 8 divided by 2 is 4, plus 6 divided by 2 is 3x to the 4th. That's all we're doing right now, is just identifying and taking out all of the common factors. We're going to get to the point where you're going to take out a GCF, and then you're going to factor a trinomial, and then there's going to be lots of things that you're doing at one time. But for right now, for our first page of problems, we're just identifying the common term. So then I come over here. What can I take out of both 2n and negative 4? 2. So I'm going to divide out that 2. We rewrite it out in front. 2 divided by 2 leaves me with n. And then negative 4 divided by 2 leaves me with negative 2. Everybody with me? Okay, good. Yeah, I'm going to go down to 4. We'll just go like in a zigzag. 3r plus 9. What can I take out? 3. Divide out that 3. Good. So 3 comes out in front. I have 3 divided by 3 is 1. 9 divided by 3 is 3. So I have 3 times r plus 3. Those two expressions are equivalent. They mean the exact same thing. They have the same value. What about 3? 4 and the n, right? So I'm going to put a 4n underneath because sometimes we forget. So just remind yourself. So my 4n, I'm going to rewrite it out in front. 4 divided by 4 is 1. What's n to the 9th divided by n? N to the what?
8.
How'd you get 8? You subtract the exponents. We have two variables, the same basis. We're subtracting the exponents because we're dividing. So this is really n to the 1st. So 9 minus 1 gives me n to the 8th. Then I have 12 divided by 4 gives me 3. And n divided by n is just 1. It cancels out. So we're left with 4n times n to the 8th plus 3. All right. This is not interesting, but this is a problem that's very helpful because you guys will see this a lot, and I want to make sure that we always follow this rule. Sorry, I didn't mean to do that. Do you see that this expression, I'm going to say, leads with a negative? Whenever your first term is negative, you want to get that out. You always want to start off with a positive. So what can I take out of both terms that will make my problem positive? A negative 3. Very good. If you lead with a negative, you want to get it out. So I'm going to divide both of these by negative 3. Negative 12 divided by negative 3 gives me positive, what? 4. So I have positive 4a. And then a negative divided by negative gives me a positive. 3 divided by 3 is 1. Whenever your problem leads with a negative, always take out a negative. If I come over here to 6. Any number in common that we can take out? No, but what do they both have? They both have an R, so you can take out just an R. My R comes out in front, and I'm left with 5 plus 4, what? R to the third. Good. Subtract those exponents. Good job. Very good. Ooh, what do you notice about this one? Okay. Oh, I'm sorry. I'm on 8. I went to 8. What do you notice about 8? It leaves with a negative, right? We got to get that out. So I know I'm going to divide out a negative something. What number goes into both 9 and 12? 3. Good. And do I have any letters I can take out? They each can have one x that I can take out. So negative 3x. Negative 9 divided by negative 3 is going to give me... Negative 9 divided by negative 3 is going to give me positive 3x. Good. And then negative 12 divided by negative 3 is plus 4. And x divided by x just cancels out. It's 1. All right, now, Faith. Which one? Oh, I didn't square it. My bad. You're right. Thank you very much. 3 minus 1 gives me x squared. Very good. Thank you. Okay, scoot on over here. Is there a number that goes into both 12 and 16? 4. Good. And do they have any letters that in common that I can take out? I can take out n cubed. Good. I can take out 3 of them because they both have at least 3. So remember, whatever you divide out goes out in front. We don't just let it disappear. It's still there. So I have 12 divided by 4 gives me 3. 5 minus 3 gives me n squared. Plus, what's 16 divided by 4? 4. And then my n cubes cancel out. Good. All right, we're going to go down to 9. Now I have 3 terms. This is a trinomial. We're going to talk about factoring trinomials a little more in just a little bit. But what do I notice about 5k squared minus 40k plus 10? They all have a 5. Let's divide out that 5 first. So then my 5 goes out in front. 5 divided by 5 cancels, so I have k squared. Negative 40 divided by 5 is negative 8k. And then 10 divided by 5 is 2. And then later on, we would ask ourselves, ooh, can I break this down anymore? You can't. This one's broken down as much as we can. But let's go on over here to 10. Oh, geez, the numbers get big. A lot of times, the smallest number can help us decide what's going to go into all 3. But you notice that all 3 of them are divisible by what number? 7? Yep. Do we also have something else in common? M's. So I'm going to divide everything by 7m. So my 7m comes out in front. 63 divided by 7 is 9. I have m to the 6th divided by m to the 1st gives me m to the 5th. Good. Minus 49 divided by 7 is 7. This becomes m to the 4th. Minus 21 divided by 7 is 3, and then your m's cancel. Good job, guys. What about 12? What's going to go into all of those? 9. Very good. So divide everything by 9. 81 divided by 9 just gives me 9. I have r squared. 36 divided by 9 is going to give me 4r. And 18 divided by 9, minus 2. Good job. What do you guys notice about this one? Okay, it leads with a negative. Could I rewrite this? How could I rewrite it? I could rewrite it in standard form. 50n cubed plus 60n squared minus 60. You guys might want to just get in the habit of doing that just so you don't forget to later on. Just get in the habit of, let me just rewrite it in standard form. Now I don't have to worry about taking a negative out or anything like that. But what can I divide out from 50, 60, and 60? 10. I'm going to take out a 10. I'm going to put that out in front. I can't take out an n because not all of them have n's, but 50 divided by 10 is 5, and I have n cubed. Plus 60 divided by 10 is just 6. n squared. And then 60 divided by 10 gives me minus 6. Questions? You guys are doing great. All right, we're written in standard form for 13, so we're good. But we notice it leads with a negative. We don't like that. So what number is going to go into negative 36, negative 12, and negative 28? Negative 4, very good. So we're going to divide out a negative 4 from all of these. So I have my negative 4 out in front. Negative 36 divided by negative 4 is 9, n cubed. Negative 12 divided by negative 4 is plus 3n. And then negative 28 divided by negative 4 is plus 7. How are we doing? Okay, let's go on over to 14. What can I take out of 18, 24, and 21? 3. Very good. So 3, 3, 3. Remember, we always look for the GCF first before we try anything else. So 18 divided by 3 is going to give me 6n cubed. Negative 24 divided by 3 is going to give me 8n. And then 21 divided by 3, minus 7. Just because the numbers get bigger, guys, doesn't make your problem any harder. Same process. What number goes into 72, 72, and 80? Agreed, 8 does. Can I take out any letters? X what? Squared. Awesome. So divide 8x squared, 8x squared, 8x squared. Good job. So that 8x squared comes right out in front here. 72 divided by 8 is 9. X to the 5th divided by x squared. That's 5 minus 2 leaves me x to the 3rd. Negative 72 divided by 8 is going to give me negative 9. 3 minus 2 is just x. And then I have negative 80 divided by 8 is 10. And my x squareds cancel. So there we go. Good job. Whoops, sorry. What goes into 15? 9, very good. Divide 9, divide 9, divide 9. Bring that 9 out in front. 63 divided by 9, 7, n cubed. 81 divided by 9, plus 9n. And then 18 divided by 9, 2. Now, 17 and 18. Do we just skip these because they look hard? No, we do the exact same thing. Treat each thing separately. Look at numbers, then the different letters. What number can I take out of 24, 36, and 60? Negative 6. Why are we saying negative 6? Because it leads with a negative. Good job. Can I take out anything else? I can take out an A from all of them. Can I take out a B from everything? No, because not every term has a B. But we have our negative 6a out in front. So negative 24 divided by negative 6 is 4. The reason why I tell you guys to write what you're dividing out underneath is because then it's really easy to see, oh, a negative divided by a negative is going to give me a positive. You generally don't miss signs as much when you actually write underneath. But I have 1a left over and then b squared. 36 divided by negative 6 is going to give me negative 6. The a's cancel, so I'm left with just a b. Negative divided by negative is a positive, so 60 divided by 6 is 10, and then my a's cancel, right? Good job. Now come on over here. Ay, ay, ay. Big ugly numbers, but that's all right. We have 2 different kinds of letters, no big deal. What number is going to go into negative 77, negative 21, and 49? Negative 7. We're going to take out that negative. Good job. So rewrite your negative 7 out in front. Negative 77 divided by negative 7 is 11, x squared, good. Negative 21 divided by negative 7 is positive 3, then I have a y. And then 49 divided by negative 7 just gives me minus 7. So tonight on your homework, at some point this weekend, you guys have a total, I think, of 14 problems, something like that. But I think 5 through 12 is just this. Just all you're doing is just recognizing what the common term is and taking it out. Nothing crazy hard, I promise. Everybody with me? All right, let's go to the next one. Re-talk about what I just did. This is your quadratic equation. You know it's a quadratic, like I just said, because it's x squared. It's the highest exponent. When we say we're factoring where a equals 1, that means the number in front of x squared, your a term, is 1. We're going to factor Monday, where our a term is not 1. It just gives us one little extra step that we have to do to solve, but it's no big deal. You guys have done this before, so we're just going to practice again. But the very first question you should ask yourself for every single problem that you factor is there a GCF? Because you've got to get that out first. So when I look at number 1, right, I'm going to refer to this because this is how it really helps us for when a is not 1. But I'm going to say always you want to take your a term times your c term. Is there a GCF? Is there a number or letter that I can take out of all 3? No. So I'm going to say a times c. So 1 times 48 is 48. I need factors of 48. And I'm going to use x's, guys. I need factors of 48 that are going to multiply to give me 48, a positive, but add to give me a positive 14. If it just doesn't jump out in your head, you might need to make a list of factors. 1 and 48, 2 and 24. 3 and 16, 4 and 12, 6 and 8. What 2 numbers have a combination that they will multiply to give me 48, but add to give me 14? 6 and 8. So you could say x plus 6, x plus 8. It doesn't matter where you put the 6 or the 8 because they're both positive. Everybody see that? If you were going to solve, then you would set equal to 0 and find, but all we're doing now is just going through and we're just factoring trinomials. Just factoring, that's it. So here again, my a term is 1. So you multiply a times c. There's no GCF. 1 times 16 is 16. What are the factors of 16? That multiply to give me 16, add to give me 10. Well, 1 and 16, 2 and 8, 4 and 4. Which one is it? 2 and 8. So I have n plus 8, n plus 2. You could have put n plus 2, n plus 8. Both the signs are the same, so that's okay. If we scoot on here to 4, okay. There's no GCF, so 1 times 18. Factors of 18 that multiply to give me 18, add to give me 9. I have 1 and 18, 2 and 9, 3 and 6. What gives me 9 when I add? 3 and 6. So r plus 3, r plus 6. Now this is really easy when we have all plus signs. When you get some minus signs in there, you got to think a little bit more, and we'll talk about some tricks that you can try and memorize if you want to, or you can just try and work it out. But again, there's no GCF here. So I'm going to take 1 times 40, and I get 40. Factors of 40 that multiply to give me 40, add to give me 14. I have 1, 40, 2 and 20, 4 and 10, 8 and 5. 10 and 4, good. Both positives in the middle, so p plus 4, p plus 10, or vice versa. Questions? All right, come down here. Now I have a minus sign. This makes us have to think a little bit more. Now we not only have to figure out what factors are going to help us, but we also have to figure out where to put the sign. So there's no GCF here, so I'm going to say 1 times positive 7. Question? Distraction? Okay. What are the factors of positive 7 that could give me a positive 7 when I multiply, but a negative 8 when I add?
Negative 1 and negative 7.
Very good. Negative 1 and negative 7. So p minus 1, p minus 7. Because remember, guys, a negative times a negative is a positive. But a negative plus a negative is still a negative. So negative 1 times negative 7 gives me positive 7. Negative 1 plus positive 7 gives me negative 8. Now, if you guys want to try and learn a trick, when the last sign is a positive, whatever sign is in the middle will be what goes in both parentheses. So like up here, right? Our last sign was a positive, so the middle sign went in both parentheses. You see that? When the last sign is a positive, the middle sign goes in both parentheses. If this last sign is negative, then the middle sign goes with the bigger number. We'll talk about that in a little bit. But that'll work if you guys are just having a tough time figuring that out. Notice that the last sign is positive. Yes? So the middle sign, we use X's. The middle sign is going to go in both parentheses. What middle sign is going in both parentheses? On number 6, what's the middle sign? Negative. So they're both going to be negative. Because we're going to multiply A times C. So positive 14. What are the factors of positive 14 that multiply to give me 14, but add to give me a negative 9? 2 and 7, right? But they both have to be negative because a negative 2 plus a negative 7 is negative 9, but a negative 2 times a negative 7 is positive 14. Again, the last sign is positive, so the middle sign goes in both parentheses. Look at 8. 1 times 63, positive 63. If you can notice this, I'm going to put an M in the front. And what is both parentheses signs going to be? Minus, good. What are the factors of 63 that multiply to give me 63 but add to give me negative 16? 9 and 7, 7 and 9. There you go. Both negative, good. If I look over here, again, I'm going to use X's. A times C, 1 times 15. What are the factors of 15? They're going to multiply to give me 15, add to give me negative 8. Well, I have 1 and 15 and 3 and 5. Since the last term is positive, the middle sign goes in each parenthesis. So each parenthesis gets a minus. And what's going to give me 8? 5 and 3. Good. Good job. All right, now this one changes a little bit. How does this one change? The last sign is what? The last sign is negative. So if the last sign is negative, then you're going to have one of each. So I have 1 times 60, negative 60. What are the factors of negative 60 that multiply to give me negative 60 but add to give me 4? So I have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. What combo is going to give me a 4? Okay, 6 and 10. Now this is where a lot of us get confused. Where do I know the sign? Well, think about it. You need a negative 60 when you multiply. That means one has to be positive, one has to be negative. But you need a negative 4 when you add them. So would it be 6 minus 10 or 10 minus 6? It's going to give me a negative. 6 minus 10. If you want to know a trick, if the last sign is positive, the middle sign goes with the bigger factor. Always. If the last sign is positive, the middle sign goes with the bigger factor. Or you could just use your brain. Whichever you prefer. All right? What goes in the front of each parenthesis? M, right? So A times C is negative 6. What are the factors of negative 6 that multiply to give you negative 6 but add to give you 1? Plus 3 and negative 2. Again, if you're like, oh gosh, I knew it was 3 and 2. Think about it. If the last sign is negative, that means you get one positive, one negative in a parenthesis. The middle sign goes with the bigger factor. 3 is bigger than 2. Yeah? All right, R and R. We could all use some R and R this weekend. 1 times negative 20. Factors of negative 20 that multiply to give me negative 20, add to give me 1. What kind of 5, what kind of 4? Negative 4, positive 5. Good. Because the last sign is negative, that means the plus sign goes with the bigger factor. Very good. Scooch on over. Again, none of these had any GCF, so I have my P and P. Factors of negative 15. They're going to multiply to give me negative 15 and add to give me 2. Negative 5, positive 3. The last sign is negative, so the bigger factor gets the middle sign, just like that. All right, and then I come to these, and it says to factor completely. That means, I'm going to have more than one thing to do. What do you notice about 3r squared, 21r, and 30? They're all divisible by what? 3. That's why we always ask ourselves for the GCF. What is a GCF between all of these? It's 3. So I'm going to take it out. So I'm left with r squared plus 7r plus 10. And then I say, can I factor this anymore? Are there factors, if I multiply a times c, are there factors of 10 that'll multiply to give me 10 but add to give me 7? What is it? X plus 5, r, and x plus 2. Both are positive because both the signs in your problem are positive. But that is factored completely. You want to take everything out that you can. Always make it as simplified as possible. Same here. What can you take out of all 3? All right, let's take out a 2. Good. So I have 2 and then p squared plus 7p plus 12. Are there factors of 12 that can multiply to give me 12 but add to give me 7? 3 and 4. Both positive. Plus 3 plus 4. I knew that because I'm trying to get a positive 12 when I multiply and a positive 7 when I add, but also because all of the signs in your problem are positive. What about here? What can we take out on 16? 3. Okay, good. So I'm left with 3 on the outside. I have n squared minus 3n plus 2. Factor that a little more. What are the factors of 2 that can multiply to give me 2, but add to give me a negative 3? Negative 1 and negative 2. Again, you can use your brain to think about that. I need a negative when I add, but a positive when I multiply. So that means both signs would be negative. But if you don't remember that, if the last sign is positive, then the middle sign goes in both parentheses, which worked right there. If we come on over to 15, what can we take out? Okay, take out a 2. So your 2 is out in front. You're left with r squared minus 8r plus 15. We can factor that a little more. We have factors of 15 that'll multiply to give me a positive 15, but add somehow to give me a negative 8. Negative 5, positive 3, good. You guys will start to see patterns. There's only so many combinations that are given that'll work out pretty. Yeah, they're both negative, my bad. Thank you. Thank you, thank you. What can I take out of 17? 3. So my 3 is out in front. I'm left with b squared minus b minus 12. Factors of 12, that'll multiply to give me a negative 12, but add to give me a negative 1. 1 and 12, 2 and 6, 3 and 4. There you go. Negative 4, positive 3. Whatever, if the last sign is negative, that means the middle sign goes with the bigger factor. What about 18? Okay, take out the 2. So I'll take out my 2. I'm left with n squared plus n minus 6. So are there factors of 6, negative 6, that'll multiply to give me a negative 6, but add to give me 1? Plus 3, good, negative 2. Since the last sign is negative, that means the middle sign goes with the bigger factor. Some of you really like factoring, you're good at it. That's awesome. Some of you don't like it. Regardless of whether you like it or not, we have to get good at it because it's not going anywhere. It's a very big part of this class, so we just need to practice and practice and practice and practice. You guys got that? All right, I need you, please.